Good morning. Myself, Prabharanjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to talk about the topic name is basic concept of Verilog HDL and its identifier from Unit 5, that is specification using Verilog HDL. From the subject name is VLSI System Design. Let I discuss. Hardware description language. Before that, we should discuss about the small introduction of hardware description language HDL, which is a specialized language used to describe, model, and simulate digital hardware systems such as processor, memory units, controller, and custom logic. HDL means a text based representation of digital hardware. HDL allows to describe logic circuit using text, simulate their behavior before manufacturing, synthesize, which is convert code into real hardware by using Verilog HDL or either VHDL. The types of HDL is Verilog HDL and VHDL. VHDL in the sense very high speed integrated circuit hardware description language. But in our syllabus we have only Verilog HDL, where we will discuss the Verilog HDL. Okay, what is Verilog HDL? Which is stands for Verilog Hardware Description Language. It is a text-based language used to design, describe, and simulate and implement the digital electronic circuit such as adder, multiplexer, counter, microprocessor, etc. Why it is called hardware description language? Hardware in the sense because it describes real digital circuits. Next, description, it explains how the circuit behaves or how components are connected. It uses syntax and keyword like programming to represent the total, which means total circuit diagram, hardware diagram. Verilog HDL in the sense a coding language for hardware. And purpose of Verilog HDL, which used to model digital system, which means either combinational digital circuit or sequential digital circuit, and simulate the circuit behavior before fabrication, then synthesis, convert the register transfer level code into actual hardware, verify that the design meets timing and functional requirement. Okay, let me discuss the design thinking based the concept. Okay. Let I discuss the second stage of design thinking, that is empathize. Empathize means understanding the hardware design challenge, which means hardware complexity. Verilog HDL helps translate human design ideas into hardware behavior that can be implemented in silicon. And designer challenges, which means engineer face challenges such as million of transistor and parallel operation and strict timing. Verilog simplifies this with abstraction. And important Verilog elements include module, which defines a block of hardware, and port, which means input and output port interface, and then buyer, which is the physical connection, and then register, which is represented by reg, which is the storage element. Then followed by, we will discuss the second stage of design thinking is define. That means clarifying what Verilog describes. Module encapsulation, which means a Verilog module represents a hardware block which exposing only necessary input output port and hiding internal logic. Then next one is data types. There are here we have used wire data type, and another one is register reg data type. Wire data type which represent the connection between the components. Next one is reg data types which represents variables or register that store value over time. And next one is description methods. We can describe the what the circuit does, which is called as behavioral. Next one is we can describe how components are connected, which structured is called by structural. There are two types. First one is behavioral, next one is structural description method. Behavioral description method, in the sense we can describe the what the circuit does. Structural description method means we can describe the how components are connected. Next stage is ideate. Before that, we will do one small activity. Here you can see the question mark. Find the value for the for that question mark and answer me through the comment. Next one is we will discuss the ideate, that is third stage of design thinking, that is ideate, which means exploring Verilog modeling styles. Three modeling levels. Verilog has three modeling levels, which is the gate level modeling. Another one is data flow modeling, and the third one is behavioral modeling. What is gate level modeling? We will see. Uses logic gates, whatever gates, AND gate, OR gate, NOR gate, NAND gate, using these types of gates for low level circuit design, uses built-in primitive gates to describe logic circuits explicitly, providing direct hardware representation. This is the gate level modeling, and followed by data level modeling, which describe what is data level, which describes signal flow using continuous assignment, describe how data moves through the system using continuous assignment and Boolean expression for concurrent operation. Next one is behavioral modeling, uses procedural block, that means always block or initial block to define high level behavior, either combinational circuit or sequential logic circuit, whatever high level behavior of digital circuits, employs procedural blocks, that is always initial, to describe complex sequential and combinational behavior at a high abstraction level. Next, designer strategically combine these modeling styles to achieve optimal balance between code clarity and synthesis efficiency. And fourth stage of the design thinking is prototype, writing Verilog code with identifier. Here one example, you can see the Verilog code for 4-bit counter. Here first is module declaration, which means module, and module name, which is counter 4-bit, and input clock reset output register. Okay, this is the 4-bit, then only 3 is 0. You can mention 3 is 0. First two is module declaration. Next one is port definition. We input output port definition. Next is here we have used always block, behavioral block. Module defines hardware unit, module keyword defines the design unit with a specified input output port and for external interface. Next one is import definition, which means specify a signal direction input and output keywords, specify signal which used to specify signal direction with register indicating storage capability. Here register used to represent 3 word, that is reg data type. Next is behavior type. Here always block, here we have used always block, describes sequential behavior which is triggered on clock edge. Always block represent two clock edges implementing sequential logic with reset functionality. Okay, this prototype show how identifier, port and procedural block comes together to describe real hardware. Okay. Okay, next, test. The final stage of design thinking is test, which means validation stage. Identifier naming, impact, clarity. Research shows identifier make up 70% of code content. Clear names improve comprehension by up to 19%. Poorly chosen or similar names increase cognitive load, causing confusion and misinterpretation, even among experienced developer. Enhancing collaborative work or hierarchical referencing. Clear, distinct names reduce error in large teams by preventing accidental misuse of similarly named variable or functions. Okay. And assessment of this lecture is, in Verilog HDL, which element defines a block of hardware with input and output? The answer is module. And second question is, in Verilog, what does a wire represent? Which is a physical connection between hardware components. This is the answer. And these all are the reference link of this topic of this video lecture. Then if you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.